All right, so since we didn't do notes last Thursday, we're going to do them for Virtual Monday instead. We're in 4-4. This is going to be angle, side, angle, and angle, angle, side. So last week we talked about side, 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 and side, angle, side. This week we're talking about some more. Just other ways to prove that triangles are congruent to each other. So this is angle, side, angle. And this one is angle, angle, side. All right, so let's go ahead and get started. These first two things are going to be on your purple page, so you're going to want to fill them in there. If two angles and the congruent side of two triangles are congruent, then the triangles are congruent. So angle, side, angle says that in two triangles, if two angles and the included side are congruent, then the two triangles are congruent. Theorem 4.5, the angle side congruent says if two angles in two triangles, so in two triangles, if two angles, oh come on, my pen is not working, there we go. If two angles and the non-included side are congruent, then the triangles are congruent. Remember, if you need to finish writing, you can always pause the video, and we are going to have 3 proofs to do. None of them are very long. I guess one of them's not even really a proof. It kind of is, but not really. So let's go to some examples. So first one, we're going to write a 2-column proof based off of this picture. We know that QS bisects PR, so this is a bisector. We know that PSQ is congruent to RSQ. So RSQ is congruent to PSQ. So those two angles are congruent. We're trying to prove those two triangles then are congruent to each other. So let's start off with some statements and reasons. Statements. Reasons. First thing we want to start with is the givens. So we know that QS bisects angle PQR, and that was given. The other thing given was that angle PSQ is congruent to angle RSQ. All right, so let's talk about this. Well, we're going to start maybe working with that angle bisector, because we know angle bisectors take an angle and they cut it in half. The definition of an angle bisector is that it takes one angle and cuts it in half perfectly. So that means that if I'm cutting that in half perfectly, and I'm going to move my line here so that I can draw some angles in here, that means that my parts of my angle on both sides are congruent. So that means that PQS is congruent to RQS because of the definition of what an angle bisector is. So let's use an angle sign. PQS is congruent to angle RQS, and that's the definition of an angle bisector. All right, so we have two angles that are congruent, and our options now are, since we're in this section, it's going to be angle, side, angle, or angle, angle, side. So I have two angles, and I can either use a non-included side. Remember, your non-included side, I don't think I went over this, but I am now. So the non-included side is either going to be RQ or SR. And the included side is the one that's going to be between them. So the included side is between the two angles. And hopefully you're like, oh, we should definitely use the included side because it's the same side on both triangles. So SQ is congruent to SQ by the reflexive property. Because it's the same side for both triangles. So now we have our angles. We have an angle here, and if I follow that triangle around, I've got a side as my next one, and then I have angles. So I'm going to use that angle, side, angle postulates. Yeah, that one's postulate. Oops. Let's say the triangles are congruent because of that. So triangle PQS is congruent to triangle RQS, and that is because of angle, side, angle. So that was example number 1. Let's look at another one. Again, we're going to write a 2-column proof. Statements, reasons. And this time we're told that DAC, so this angle here, is congruent to BEC, which is this angle down here. And we're also told that DC is congruent to BC. So DC, which is this side here, is congruent to BC, which is that side over there. All right, so it's kind of hard to tell these two triangles apart, so I'm going to just highlight them in a different color so that way we can kind of see what is going on here. And then we have this orange one. Okay, so let's start off with our givens. Angle DAC is congruent to angle BEC, and DC is congruent to BC. All right, so we need to either use, oops, did not mean to do that, angle, side, angle, or angle, angle, side. In this particular one, this is kind of a short one. It is a really short one, actually. Hopefully you're noticing that both triangles share something. Oftentimes when we prove triangles, they're going to share something of some sort, and in this case, they both share this side C, or this angle C. So angle C is congruent to angle C for both triangles because of the reflexive property. If it's the same thing, always use the reflexive property. So now we have an angle, we have a side, and we have an angle. And for the other one, we have an angle, a side, and then an angle again. So this time we are using angle, side, angle once again. Hang on, let me back up. It's not angle, side, angle, and here's why. Because DC is not the line for that triangle. So I have an angle, and then this line DC here is not a side for that triangle because it's not the whole way. So then I have an angle, and then I have the side up here. And now for the other one, I have an angle, and then a side. So this one's angle, angle, side. right, last one. And I might have to add another page here so that I have enough room to write. All right, so Jeremiah is working with a community service group to build a bridge across the creek at a local park. The bridge is going to span the creek between the points C and B. So it is going to span this length here. So span the points between C and B. Jeremiah located a fixed point at D. So D is fixed. It's not going to move. Oops, that's not what I wanted to do. Come on. There we go. To use as a reference so that he can have segments with relationships shown. A is the midpoint of CD. So A is a midpoint. And DE is 15 feet. So we know this here is 15 feet. It's kind of hard to read that. Let me see if I can use another color. That's easier. There we go. We need to finding how long the bridge is. So we need to find out how long this length is. All right, so a way that we can do this is that if we can say that these triangles are congruent, then we can figure out really easy what that is going to be. So we already know that D and C are congruent to each other because of what we have in this picture. We have that this is a right angle here and that's a right angle there. So we know D and C are congruent. So angle D is congruent to angle C. And I'm not going to write this one as a proof because we're not really asked to prove anything here. So angle D is congruent to angle C. We also know that A is a midpoint of DC, and because of what a midpoint is, we know that those two sides are congruent. So we know that CA is congruent to DA because A is a midpoint. All right, so we have an angle, we have a side. So since we're in the section with angle, side, angle, and angle, angle, side, we're going to need another angle of some sort because all of these have two angles in them. So we could figure out maybe a way to say that B and E are congruent, but that's going to be kind of difficult. Hopefully you remember that if I was to draw something like this, 3 and 4, I could say that 1 and 3 are congruent angles because they are vertical angles. So here I can say that BAC is congruent to EAD because they are also vertical angles. So because I now have angle, side, angle, they are congruent because of that angle, side, angle, which means that DE is congruent to BC, and if congruent parts are congruent, then it is going to be 15. There we have it. So, like I said, not a very long one. There are going to be, I have a few questions for you, and then you will be good to go. So, let me scroll down, add a few questions here at the bottom. You're going to answer them here on the Ed puzzle, and then we'll be all hunky-dory. So, questions to answer, basically your exit questions. So that way I can see how well you understand this stuff. The first one is, what type of congruence can be used in these? So I'm going to do this. what type. So the first one is going to be this picture here. My triangles always tend to look the same, no matter how hard I try to draw them different. You're going to choose angle, side, angle, 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 side, or not enough info. So 2 is going to be this picture. And 3 is this. So you're going to choose which one it is, and then you're going to move on to the next section. So there's those 3 questions. I'm going to give you probably 3 more questions. I know there's a lot of questions, but I have to check for understanding somehow, and because you're not sitting in front of me, this is how we have to do it. So 3 questions there, and then your last 3 questions are going to be what information. So 3, this is 4. What information do you need to use angle, side, angle given this picture? Number 5, what information do you need to use angle, angle, side? Should probably label these points B, A, D, C, D, E, oops, F, G, H, all right, so there's your next 2 questions. What information do you need to use angle, side, angle for number 4? Number 5 is what information do you need to use angle, angle, side? And the last question, like I said, there was going to be 6 questions. You're going to have a fill in the blank proof here. So the last one is you are given angle D is congruent to angle F and EF is parallel to GD. Prove triangle DEG is congruent to triangle FGE. And this is what your picture is going to look like. You're told that D, F, G, you're told those are congruent. All right, so you're going to fill in the proof, statements, reasons, let me put this elsewhere because it's going to be really squished. All right, statements, reasons. All right, so your statements that angle D is congruent to angle F, that was given. EF is parallel to GD, that was also given. Angle F, EG is congruent to angle DGE, and the reason is if lines are parallel, then blank angles are congruent. EG is congruent to EG because of the what? And then triangle DEG is congruent to triangle FGE. FGE because of what? All right, so this is the last one. I will have boxes in here if you haven't already seen them to answer them. Have a great rest of your day, and hopefully you learned something.